Hello everyone, my name is Paz Arroyo. I'm an adjunct assistant professor at Catholic University and also a senior coach at the Project Consulting. We did this research with Gabriela Correa, who is a master's student at Catholic University, Professor Claudio Burgues from Catholic University, and also Forrest Flagger from Stanford University. So we're going to compare choosing by advantages and weighted rating calculating large design spaces. So either conscious or not conscious, we make hundreds of decisions in every single construction project. So what we're actually doing there when we make decisions is shaping the future and how the building in a particular case will look like, how the future of the people that will use the building will experience it, the people that live nearby the building will experience it, and also the impacts in the environment, etc. So if we want to make good decisions, we want to explore large design spaces so we have better options of getting to a better decision. So computers can help us to do that, but even when computers can create large design spaces, we still, as human beings, need to make the decision about what the future will be. So there's evidence that choosing by advantages is better than weighted rating calculating in small design spaces. We have proved that what people can get to consensus faster, with less frustration, because CBA helps decision makers to make judgments based in a context that is more realistic, so therefore they can imagine the future better. But this paper is about what happens when you're in a large design space and how do you compare choosing by advantages with weighted rating and calculating. So what we did in this study was to create a large design space using multidisciplinary design optimization. And then we, in a charrette, we asked practitioners to use weighted rating and calculating and then choosing by advantages. And we made the analysis of what was the result of this decision. So the case study is a project in Orlando, Florida, and the design space was created by changing certain parameters of the building. So millions of alternatives were possible, so changing the building aspect ratio or the glazing percentage or the types of materials, etc. So for our research, we took 1,000 alternatives using the full range of performance of the millions of alternatives that were created by this computer. And these are the range of the performance for the factors that we use as a proxy to judge the future of the building. So we took VOC emissions, energy consumption, acoustic performance, and cost. So the first thing we did is ask practitioners to use weighted rating and calculating. So to do that, they have to decide what is the most important factor for judging these decisions. We did that online. They didn't have any issue answering those questions. Yeah, I know if people know CBA, this is not a sound question, but they didn't have any issue answering those. And then we used the full range to normalize the data, and with that, with the normalized score for each alternative plus the weight of the factor, we calculate a scoring system, which is the traditional way of making decisions in construction. And we made this a ranking, and we select the alternative with the best score. So that's weighted rating and calculating. I think it's familiar for most of the people. So then we did, we teach the practitioners, the same practitioners that made a decision using weighted rating and calculating, how to use CBA. We asked them to do it with only 10 alternatives so they could make a better assessment of what the difference between these 10 alternatives were and how the different disadvantages were valuable for them. So different from WRC, they were not making linear trade-offs. They were not assuming that there were linear trade-offs. They were looking at the advantage between one alternative and the other, and weighted the importance of the advantages afterwards. So we took that preferences and we generalized it to the whole design space, which were the 1,000 alternatives. And then we did a chart that plots the importance of advantages and the cost of the alternatives. And then practitioners had to decide what was the preferred alternative. And after they did that, choosing by advantages, we put on top the decision that they previously made using weighted, rated, and calculated, and we asked them to make a final decision which one they will take. And then we asked them to answer a survey. And Tommy will say the results.
Thank you, Paz. Good morning. So this table basically summarizes the results of the experiments that Paz was explaining. So and we're going to show some graphs to better explain the concept, but here it's good because it summarizes everything. So you can see in the second column that it's showing whether the best alternative, the best solution, the optimal solution obtained with the WRC, the weighting, grading, and calculating method, was or not in the optimal frontier that was delivered by the CBA method. And you can see that in 4 cases they were not, and in the other 7 cases, in 4 out of those 7 cases, they were in a very poor optimal position. I'm going to show that and explain with more detail. Also, we can see in the third column that most of the cases, the solution that the WRC method delivered was different from the one obtained by CBA. Just in 2 cases were the same. So the practitioners obtained a solution that was in the Pareto frontier, and it was the same solution that they selected with the CBA method. And then when, as Paz explained, when we asked them to decide if they would, we showed them both solutions, their WRC solution and the CBA, and we asked them if they wanted to change. In most of the cases, they changed it to a CBA solution that was in the Pareto frontier. And in 2 cases, they kept the same alternative, but those are the cases that also it was the same alternative, WRC and CBA, so it really made sense to keep it. And just in 1 case, the practitioner, in case number 7, he kept the WRC solution, even though it wasn't an optimal. It was a poor optimal. So here you see this graph where you have the importance of the advantages and the cost. So you can see the trade-off. All the dots there are the 1,000 design alternatives. So you can see immediately that it's a lot of it's very good information to make a decision. So the idea is to choose alternatives from the Pareto's optimal frontier. That is the curve that is joining the top order. Thanks. And here you're seeing the 4 out of 11 cases that the WRC solution was not in that Pareto frontier. So with those lines, we can define the top left quadrant that all the solutions that are in that quadrant are better than the solution that was selected with the WRC method. So it has either or more importance of the advantages or lower cost. So the other solutions, 4 out of 11 that were in the Pareto's frontier, the WRC solution was in the Pareto frontier, were poor because basically there were solutions to the left, if we zoom in, that had a very small reduction in the importance of advantage, but they were much cheaper. So basically they could sacrifice a little bit of importance of advantage, but having a much, a big saving in cost. And then, of course, you have these 3 out of 11 cases where the WRC solution was on the Pareto frontier. In this case, 2 of these cases had chosen the same alternative with the CBA method. And the third one changed later on his decision to another one, to the other one that was selected with the CBA method. So we also asked the practitioners about the transparency, and they mentioned that the CBA was much more transparent. It gave them much more information, and they could see the difference and understand the relationships, why the alternatives were, one was better than the other one. And also they declared that they would choose to use CBA over WRC in a similar decision to the one that we faced in the experiment. So the last one. So what we learned is that we can produce better alternatives using CBA when we are in this context of large design spaces like the ones of the experiment, compared with the WRC method. And CBA allows us to choose always from this Pareto frontier. We can see that, and it's possible to compare the benefits of the alternative instead of just obtaining a linear ranking of them and then choosing the top one. The fact that also the WRC delivers solution outside the Pareto frontier, or on these poor positions that I was explaining, is due also to these prejudices and assumptions that are not clear to the decision maker in terms of the linearity of the preferences, and also this really what they mean with when they put the weights in each of the decision factors. So with the last 2 seconds that I have, I just want to invite any company that is interested in applying this kind of methods in large design spaces with you, because we want to repeat this experiment with more practitioners and more cases. We leave you with that invitation. Thank you.
Ralph Edwards, California.